Hello. So this is the Exam 2 review for spring 2018. So these are going to be the review slides. So this is going to be just like with the other exams. These are going to be the free answer parts. So I'm going to have you draw two isomers of a molecule with that. So and then I'm going to give you the formula. Right? So with that, so I'm going to give you a formula, and I'm going to give you a functional group. Okay, so you need to know what the functional groups are. So in this case, the alcohol, which is an OH group. OH that's not attached to a C double bond O. If it was, then it would be a carboxylic acid. Nor is it next to a benzene, stuff like that, which would be a phenol. So for this one, the first thing you may want to do is to just do a quick DOU calculation. So it's 2C plus 2 plus nitrogens minus X minus H all divided by 2. So this is going to let you know if there's going to be any rings or double bonds in there. Okay, so for this molecule, right, 2 times the number of carbons, so it'd be 3, plus 2. There aren't any nitrogens, no halides, but there are 8 hydrogens, all divided by 2. Right, so it ends up being, right, so 8 minus 8 over 2, so it's 0. So there's no rings and no double bonds, so like that. So we know that the carbons are going to be in a line. So 1, 2, 3. Okay, so we can put, say, the alcohol group, say, here, and then fill in the hydrogens. Right? So hydrogen, hydrogen. You could do it as a skeletal structure, you can do it as a condensed structure, doesn't matter. Sometimes with a small structure, sometimes it's easier just to do a loose structure. The other thing that you could do for this one is, say, put it here, which would be, and then fill in your hydrogens. Right? So with that, and so for this one here, right? Now you would say, like, well, why couldn't you just do, say, this one? So CH3, CH2, CH2 here. Why couldn't you do that one? So if you put these two in here, the problem is these two are actually the same molecule, right? And you can name them if you wanted to, and that would do this, right? Because for here, the ends, you do the OH. The OH has the priority, so the numbering would start 1, 2, 3. For this one, right, it's not 3. This is the end where the OH is, so this would be 1, 2, 3. So these would both be 1 propanol. This one, however, since the OH is in the middle, it would be 1, 2, 3 like that. And so this would be 2 propanol. 1 propanol, 2 propanol. So you would need to do 2 of these. Now you could do this one, or these two, but one of these, and then this one. Okay, for this there. And again, you can draw it as a condensed structure, you can draw it as a Lewis structure, mix and match, doesn't matter. I don't care. So you just need to make sure that they're different molecules. Okay, so I will give you some actual DOU, and this will be on your equation sheet. Okay? So for this one, right? See this in red so you can see it. So the DOU, right? 2 times the number of carbons, so it's 8, plus 2, don't forget the plus 2, 1 nitrogen, 1 halide, and then 8 hydrogens, right? So 2, right? So this is 16, 17, 18, 19, so this is 19 minus 9 by 2, so it's 10 over 2, it's equal to 5. Right, so some combination of double bonds and rings, that's 5. Like that, so that's fine. As long as this is a whole number that's 0 on up. You can't have a negative. You can't have a fraction. So this, you can't have 1.5 because you can't have half a bond or half a ring. So like that. So what's probably happened, either one of two things. You've either switched one of the signs here, or you've forgotten the plus 2. With that, so that's usually the common mistake. Okay. So for here, I'm going to give you a molecule. You need to circle the functional groups. Now, again, you don't have to do alkanes, cycloalkanes, or benzenes, stuff like that. So here, so these are benzene. This one here and this one here. These are benzenes. so you would not actually have to mark these. Okay? So don't worry about them. Okay? I'm going to mark them here just so you can recognize them, but you don't have to. But for here, right, we have a C double bond O, so we need to look on either side. So for here we have a carbon group. Here we have an O carbon. It's a benzene, but that's fine. O carbon. So this guy right here, this is an ester. Come on. So for that, it's not an ester and an ether. It's just an ester. This oxygen is part of the ester group, so it can't be part of any other functional group. Okay, so for here, right, there's an OH here, right? You can say like, wait, oh, that's connected to the benzene. But there is a carbon here that separates them two, so it's not a phenol. It's just a regular alcohol. Oop. Will you stop? Oh. It's just a regular alcohol. Now, if there was a C double bond O here, that would make it a carboxylic acid, but there's not. It's just a regular old carbon. Okay? Again, we have a benzene here. Now for here, we have a nitrogen, and you have to look to see, is there a C double bond O here, here, or here? It's not, and so this would be an amine. Now, if there was a double bond O, say here, then it would be an amide, but that's not what we have. Right? We just have a nitrogen. It's got regular old carbons next to it, no C double bond O's. It just so happens to not have any hydrogens. That's fine. So for that, but it's an amine. So, okay, you are going to have quite a few naming molecules. You have to do the name, but that's so. These are at the end of the slide deck. There's also a bunch of these at the end of the slide deck as well. We're not going to go through those, but you can go in and practice with those. Now we are going to have a couple where I'm going to give you the name and you have to draw it. These are usually really simple, stuff like that. Because what you do is you go backwards. Okay, so you start with the main chain right here. The main chain is cyclohexane. So, okay, so for this one, right, we can designate where number 1 is, right? So let's say it's 1. 1, 2, well, here actually, I don't know. Let's start it here. So 1, 2, 3, 4, 5, 6. We can start wherever we want to. Now we have it, right? We have a 2-propyl group hanging off of carbon 2. So at carbon 2, right, we have an isopropyl group, a 2-propyl, right? So we have that. And then we have a methyl group hanging off of carbon 1, so that. And then we have a bromine hanging off of carbon 4. Ta-da! That's it. So just go backwards and you'll be just fine. Right? Start with your main chain and then work backwards. 2-propyl group hanging off of carbon 2. A methyl group hanging off of carbon 1. Bromine hanging off of carbon 4. And that's it. So, not too bad. Okay, and then we'll go in there. So, okay, so good luck.